When working with logarithms, there's another base besides the common log base 10 that comes up an awful lot, and that base is the number e. E is actually used as a constant. It's approximately equal to 2.718 blah 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 blah. It's kind of like pi, one of those irrational numbers. It's a non-repeating decimal that goes on forever and ever and ever. But it comes up in a lot of very interesting applications that are dealing with continuous growth or continuous decay. So things like radioactive decay problems, population growth problems, extended compound interest problems, any of those situations where there's some sort of continuous compounding, continuous growth, or continuous exponential loss going on, this constant value ends up coming up over and over and over in nature, kind of like pi always comes up when you're talking about circles. So when we look at certain problems, the calculator has been programmed with this natural log in there. And that is this ln button that we see in there. So the natural log is the ln. And all that the ln means is that it's just a logarithm, but the base is e. So how do we work with that when we're dealing with solving equations where x is in the exponent? Really, we don't do anything special. It's just if you ever come up with a situation where you have a logarithm with a base e, just remember push the ln button on your calculator and that'll get you your value directly. So let's take a look at problem 22 here. Here we have e to the 3x equals 15. X is in the exponent. I need to get it by itself. The only way to get it out of the exponent is by switching it to logarithmic form. I have a base, a power, and a number, so I'm ready to go. And if I switch to log form, we have log base e, zigzag over to pick up the 15, is equal to my exponent, which was 3x. Now, because I have log base e, remember log base e is the ln function on your calculator. So when you go to evaluate this specific problem, all we need to do is figure out what the ln of 15 is. And you can just push that button right there, and we end up with 2.708. We'll round that up to 1. And that's equal to the 3x. So x is not quite by itself yet. You'll still have to do one final step here of dividing each side by 3. We can do that on my calculator here. Divide that last answer by 3, and we get 0.9027. In terms of my value for x. So if x is in the power, we still switch it to log form. It's just if it's log base e, you want to push the ln button on your calculator. All right, let's take a look at 23 here. Here again, I have x is in the exponent, so I'm going to need to switch to log form. Before I can switch to log form, I need just the base and the power to be by itself. So in this particular case, I'm going to need to get rid of the -1 that's here and the 12 that's over here. We do reverse order of operations, weakest link first. The -1 we're going to have to get rid of by adding 1 to each side. That's going to cross out and leave me with 12 e to the 5x is equal to 1.2. Now if I want to finish solving the problem, again, x is in the power, e is the base, not the 12, so I'm going to divide by 12 on each side next. On the left, the 12's cancel and leave me with e to the 5x. On the right, I do 1.2 divided by 12, which is 0.1. Again, all right, so far so good. X is still in the exponent. In order to get it out of the exponent, I need to change it to logarithmic form. And now that it's just the base and the power here on one side of the equal sign, I can do that. So here I'm going to have log, my base is e, zigzag over to pick up 0.1 is equal to 5x. Recall that log base e is the ln, and so I can find the ln of 0.1 on my calculator. So I come up over here, the ln of 0.1 is negative 2.3026. Let's slide this over here. So coming up here, negative 2.3026 equals 5x. And then we can divide by 5 to finish getting the x by itself. And I get negative 0.4605. equals x. And that works great. So that would be my solution for x in that particular problem. So again, if you see log base e, change it to ln, just continue on with the problem as normal. You're just going to push a different button on your calculator. Now, if your x is inside the ln, then the only way to get x out of any type of logarithm is to change it to exponential form. So when we go to change this to exponential form, and if it helps you, go ahead and rewrite it. Ln means log base e of x. So in this particular case, my base is e. Come over here to grab my power, equals, and then whatever was inside the logarithm is now by itself. So in this case, that got me my x all alone. On the left-hand side, what I have is e to the second. And remember, e is not a variable. It's actually a constant value. And we can find it located on your calculator. Because e and ln are inversely related functions to each other, you usually will see an e to the x button as part of some sort of second function with the ln. So in this case, I'm going to be able to pull up e to the x by hitting second ln. And with almost all e to the x buttons, what you do when you push that, it's waiting for an exponent next. So in this case, I want e to the second, so I'm going to hit e to the 2, hit enter, and I get 7.3891. That's what e squared is, and my x is by itself, so I'm finished. You can still, for other calculators, let's see if I can pull that up here real quick. Should have had this up already. Calculator. Where'd you go? There it is. Okay, so here, notice that there is a, the ln button's up here. So if we want to find e to the second power, you're going to put in the second power, and then you're going to hit inverse, and then notice that the ln button changed to e to the x. So we want to then, you can hit equals, and there's my 7.3891. So inverse ln will pull up that e to the x, but you, with the scientific calculators, you often need to hit the power first and then do that button. So play around with your calculator until you get this value when you're trying to evaluate those particular functions. In problem number 24 here, we have 2 times the ln of 3x plus 1, and then we want to subtract 5 from that to get 3. Again, the x is trapped inside the logarithm, so I will need to switch to exponential form, but I need just the logarithm by itself first. So first thing I'm going to need to do here, with the weakest link, we're going to get rid of the minus 5 by plussing 5 to each side. It's going to leave me with 2 times the ln of 3x plus 1 equals 8. Next, I'm going to divide by 2 on each side to finish getting that logarithm by itself. So I have the ln of 3x plus 1 is equal to 4. Now to get the x out of the logarithm, so I can't do anything else because all of the 3x plus 1 is trapped in the logarithm, so I have to get it out. Remember that the ln just means log base e of 3x plus 1. And so now I can change it to exponential form instead. So e is my base, zigzag over to grab 4 as my power, and that's equal to 3x plus 1. So I need to figure out what 3 to the 4th power is. And pull that up on my calculator, whichever one you want. E, again, is going to be that second ln function, and I want it to the 4th power. It gives me 54.5982. And that's equal to 3x plus 1, and then I need to finish solving to get x by itself. Subtract 1 from each side, that's going to give me 53.5982 equals 3x. And I can finish by dividing by 3 on each side. Slide that up a little there. And x is equal to, let's go ahead, 53.5982 divided by 3. And I'll get, forget that it does that, 17.8661. As my solution to that particular equation. So again, ln is just log base e, or if you see e to a power and you're switching it to that log form, then we can use the ln button on the calculator instead of the common log button.